There are three specific incident rays which we can determine the direction of reflection fairly easily. Okay, so I still have my object, the teddy bear over here, and I have a concave spherical mirror over here. I've labeled the center of curvature, and I've labeled the vertex over here. So we'll start to investigate some of the rays which we can easily analyze. The first ray will be the ray which is coming parallel with the optic axis. We know that this gray line over here represents the optic axis. So if our ray is coming in with a direction which is parallel to this optic axis, we will know that the reflected rays will be directed towards the midpoint between the center of curvature and the vertex. Okay, so this point over here is the midpoint between the center of curvature and the vertex. And if you look at it, if you try to draw the normal line will be pointing like this, and you'll see that it makes sense. The angle here will be the same as the angle here. Okay, so this midpoint between the center of curvature and the vertex, we call it the focal point, and we label it by the symbol small f. So over here I label this symbol small f to represent midpoint between the center of curvature and the vertex, and this focal point will be very important for our future discussion. Okay, then this is the first ray. The second incident ray that we can draw is the incident ray that passed through the midpoint between C and V, which we just now call it as focal point. So if our incident ray is passing through the focal point, you know that the reflected ray will be parallel to the optic axis. Well, you can see that it's the opposite of 1 actually. If something is coming in parallel, it will come out hitting the focal point. If something is hitting a focal point, when it comes in, it will come out to be parallel. So it's a direct opposite. It is telling you actually that if you send a beam this way, you actually get reflected this way also. Because you can think of the arrows as reversible actually. So if 1 is true, then 2 must be true as well. So actually using this two lines here, we can see that the intersection is here. This is not the intersection that we care. This is the intersection that we care. So from here we can straightaway know that actually this is where the image will be. Okay, it will be below the optic axis. But let me finish up and laying out all three incident rays that you can use to draw your ray diagram. So the third one will be the ray that passed through the center of curvature. Okay, so your ray is coming again from the same point here, but it will be directed towards the center of curvature. And if that's the case, right, the incident ray, right, is actually incidenting on the normal of the plane itself. You are shining your light on the normal on the plane itself, so of course you get reflected in the opposite direction along the same path back towards the object. Okay, so this path here, you can see the reflection is anti-parallel with the incident rays. And again, you can see that this blue ray, this green ray, and orange ray all intersect at the same position. So this position here, we actually call it image point, but I will elaborate on it in a few slides later. So we know that our ray is now coming this way, and coming this way. We figure out that the intersection is over here. So we know that this point, we can call it the image point. Okay, the point where we start from, we call it object point. The point where we find it intersects, we call it the image point. In that case, we can think of the image as being inverted and it's smaller and it's placed over here. Okay, I hope you are able to imagine it. Try to put some thoughts into it. Okay, so now I'm going to label some of the important parameters that we will use in our calculation when we are dealing with geometrical optics. Okay, so these are the things that we usually label when it comes to describing our object and our image. Okay, the first thing that we usually label is the object height and the image height. H subscript O and H subscript I. So this one will be the height of the object. This one will be the height of the image. Okay. Then after that, you'll be studying the object distance and the image distance. So for object distance is the distance from the object point to the vertex of the mirror. The vertex of the mirror, that's the distance, and we call it by u. Okay, it's similar to initial velocity, final velocity, right? It's the initial distance, then the image distance. The image distance, we call it v, and it's the distance between the image point and the vertex of the mirror. So these four parameters here are important when it comes to calculation in future videos. Okay, so when we manage to figure out the image, right, it's also important for us to elaborate on the characteristic of the image. I believe you have remembered those magnified, diminished, all those kind of stuff, right? So let's try to analyze it one by one. The first aspect, the first characteristic you need to analyze is whether it's real image or a virtual image. Okay, a real image, it's formed if the intersection is formed by solid lines. Okay, for now you can see all lines are solid, so you might not be able to imagine what the dashed line means for. Okay, but we look at it in concave mirror later. Okay, but for now you can see that the three rays are all solid rays, means that the light actually passed through this intersection point. Okay, it's actual light that is passing through this intersection point, so therefore we call it a real image. Okay, so let me circle it. Real image is the answer. The next one will be whether it's upright or inverted. Well, if it's upright, then the image will be above the optic axis. If it's inverted, it should be below the optic axis. So in that case, I think it's quite straightforward. It's the image point is below the optic axis. Therefore, our image is inverted. Okay, then the last characteristic that we usually identify is whether it's magnified or diminished. Well, to determine whether it's magnified or diminished, you can just compare the arrow here. You can see that the object height is quite big. The image height is actually quite small compared to the object height. So we can conclude that it's actually a diminished image. So answer is diminished. So you usually describe the characteristics of your image based on these three characteristics, whether it's real or virtual, whether it's upright or inverted, or it's magnified or diminished. So this is one of the many cases for concave mirror. You can be shifting your teddy bear towards here, nearer, pass through the center of curvature, pass through the focal point. You can have your object at various distance and you produce image of various characteristics. So we'll be doing practices on that in the future.